Welcome to the design patterns series. In this series, I will show you how the Gang of 4 design patterns can be implemented using Ruby. I learned this thing during the RailsConf from the presentation done by Neil Ford. So the material is based on the examples he gave, but I have taken out a lot of baggage out of it by just removing all the assertion. Everything was written using test unit, and I wanted to just reduce it, boil down to the very basics and minimal examples that just focuses on the techniques of implementing reason patterns in Ruby instead of just getting distracted by the tests that you have to write. Okay, let's get started. The very first pattern in this series will be iterator design pattern. Whenever you're working with a design pattern, it's a good idea to understand the intent of that particular design pattern. In the case of iterator, this is the intent. The intent of iterator design pattern is to provide a way to access the elements of an aggregate object sequentially without exposing its underlying representation. So let's see an example. The print takes any container. Result is where I will accumulate the results, and I will iterate through this container. And I'll just add the value in the container to the resulting string, separated by spaces like this. Whatever the element for that particular index is, and then a space, then return the result. If you had seen the previous screencast, you can see you have an object. It's kind of like string.new here. You do something to that object here, and then you return this object. It's kind of like a idiom we saw. It's the same idiom we saw in the previous episode where the returning was used to simplify. So this happens quite often when you're working with Ruby, and using returning is not a bad idea. So let's say I have the containers for the first test will be some numbers. And then I also want to have another container called words. It's just an array of strings. Let's print the numbers. As you can see, it prints all the numbers separated by spaces. I can also print the words 1, 2, 3, 4. Okay. Now here you can see this is a external iterator where you're iterating over it and you're aware of the container. So there is a looping logic here. How can we do a internal iterator? I don't want any looping logic at all, and I want to provide a way to access the elements of an aggregate object sequentially without exposing its underlying representation. That's the essence of iterator, right? So in that case, what I can do is I can say container dot each do, and I need a block variable to access each element, and that element will be accessed here. let's run this again. Okay, there is no ix. We're not indexing. We're not now aware of any indexing or looping, anything to do with the looping stuff. We just get the element. Right. So let's run this. There it is, 1, 2, 3, 4, and we can also print the numbers. 1, 2, 3, 4. So as you can see, number one, there is no looping logic. The looping logic does not, when I say there is looping logic, but it's not aware of the internal implementation details. We are not exposing any index, and we are just able to operate at a much higher level of abstraction here. So if you compare this implementation with the intent of the iterator pattern, as you can see, it does provide a way to access the elements of an aggregate object sequentially without exposing its underlying representation. See how simpler this thing is when compared to this. So we have an aggregate, we have a concrete aggregate, and I'm not even going to go into details of how you would actually do this. And ceremony versus essence. Ruby captures the essence in a very concise way you can write, and you don't even need all these unnecessary classes that operates with each other, and you are having this abstraction of first, next is done, and you're still aware of the looping and when you need to stop and all that, whereas Ruby just allows you to implement it in a much simpler way. Hope you learned something from this episode, and if you enjoyed it, please recommend me on Working with Cells. Thank you.